Okay, today's lesson we're going to look at doing reflections, stretches, and translations all at once on a function or on a graph. So we're going to be combining these things in different orders. So we just got to figure out how we can do these kind of questions with more than just one transformation happening. So the first thing we want to do is when we're completing multiple transformations, we're sort of following order of operations. So we want to do sort of your bed mass type thing. So that means we're going to do sort of the dividing, multiplying type stuff first. So that would be our stretches, because we're usually multiplying by a number or a fraction, which would be dividing. And reflections are still sort of part of that because we're timesing or dividing by -1. So those two go first, and it really doesn't matter what order they go in, but just sort of pick it and keep it consistent. And then our translations are adding and subtracting, so we do those ones last. The key thing that we want to deal with is if we have more than one thing going on, we want to write our formula typically like this, but it can be written in different forms. The key thing to remember is our vertical translation goes with the y, our horizontal goes with the x. Then if we have a stretch and reflection, those numbers go out either in front, so our a would be for our vertical, or we could write it as 1 over a in front if we wanted to do that. And then our b, remember, is the reverse, the reciprocal, and that goes in front of the x. If you notice on this formula, there's sort of an extra set of brackets compared to how we would normally write this. So, oops, I lost my question here. Here, I'll just go to the next page and we'll go from there. So, our equation was y equals a f of b x minus h, and then we had minus k, I think, as we had, or plus k, sorry. So when we're dealing with this, we want to sort of track that extra set of brackets. So what that means is we have to be careful if we have a horizontal stretch and a horizontal translation going on at the same time. We want to make sure that translation's in this smaller set of brackets because it affects only the x, and then the b, if we were to FOIL it out, would actually change that number. So we got to be just a little bit careful when we deal with those. But other than that, you should be okay with doing these processes. So step one, we want to do a horizontal stretch or vertical stretch first. Then we want to do our reflections, then leave the translations last. And the key thing is always just make sure you do your translations last. Let's go through a couple examples. So this first one, it shows our original equation is absolute value of x. So if you remember, that's just a V-shaped kind of graph that's drawn here. So now what we want to do is these kind of translations. It's a good idea if you list them out so that you remember what's going on. And actually, there was a mistake on here. Let's put a set of brackets. That should be a set of brackets like that. So when we do this translation, let's kind of list out what's going on, and then that should help us be able to draw or figure out the new graph. So first of all, we got y plus 2, so that would be 2 units down. Then we've got this negative out front, so that's vertical reflection. Then we have a 1/3 out front, so that would be 3 times horizontal stretch. And then the last one is we got the -4, so that would be 4 to the right. So there's our 4 transformations, so now we just got to be careful of order. So let's stick with the SRT, so we're going to do stretches, reflections, and then translations. So let's do the stretch first. We got a 3 times horizontal stretch. So remember, then each horizontal coordinate is going to change to be 3 times bigger. So our 0 times 3 stays the same. This one that's here, that's at -1, it'll move to -3. The one there that's here at +1 will go to +3. And we can do maybe one more. Let's jump up here. So if we're at 3 times 3 would be -9. And +3 will go to +9, and that's enough to draw our graph. So far, just with the horizontal stretch, it should look something like that, so widened V shape. Now let's do our reflections. I'll do that one in a different color. So let's do reflection next. We've got a vertical reflection, so that means all of these vertical coordinates are going to get reversed. So here we were up 3, we're going to go down 3. Same thing over here, up 1, go down 1, the other one go down 3. And we're good. Oops, I messed up on that one. So we've got our downward V shape. It's going to look something like that. And then last, we can do both transformations. Usually it's easy enough to do both at once. So let's do the last step. Let's do 4 right and 2 down all together. So we'll just kind of combine those two. So we'll take each coordinate now. Let's go 4 to the right and 2 down. So that would be our origin. Take the next one. 4 to the right and 2 down would be to there. The last one, 4 to the right is over here. 2 down would be something like that. So there's our one side. And then do the same thing for the other coordinates. 4 to the right and 2 down would be to there. Our last one, 1, 2, 3, 4 to the right, 2 down would be over there somewhere. And there's our graph. So our final graph would be this green one. So it's a good idea if you're drawing these, sketch them in steps, like do it in different steps, otherwise it gets a little bit too confusing, but always do your stretches or reflections first, then your translations last. Okay, here's another one. Let's go through it sort of the same way. So we've got a -5, so that means we're going 5 up. We've got a half out front, so that's a 1/2 vertical. And then we've got a negative inside with the X, so that's a horizontal reflection. And that's it. Okay, so there's our original graph, so it's some sort of weird shape, so we're just going to take the transformation for this stuff again. So once again, let's do these in steps. So first step, we'll do our stretch. We're going to go 1/2 vertical, so that means every coordinate will be half as tall. So the 6 will go down to 3, this 6 will go down to 3, the 0 stays the same, 2 down to 1, 0 stays the same, and then our 6 down to 3 again. So you can see our first vertical stretch then is half as tall. Now let's do our reflection, our R. So each coordinate, so this one is going to move over to the other side and vice versa. So those two are the same, let's stay the same. These two will trade spots. This one will go over to here. Our bottom one will go to -4 and our other one will go up to -5. So our W kind of thing goes like that. So we've taken care of the reflection. And now the last step is do our 5 up. So take every one of these coordinates, move them up 5. And just plot those points just to make sure you don't mess it up. And we should be good. So our W will go like that, go over and down. So that would be our final graph for that one. Okay, last example, sort of the same but kind of in reverse order. This time they give you the graphs and they're trying to figure out what the equation would be. So f of x is our original, so that's the dotted line at the top. So let's do sort of the same thing, let's figure out what went on. So we know that it got reflected vertically, right, because it's now upside down, so that's good. So now the next thing is we want to figure out, is there been a stretch? So if you look at the original, and let's kind of compare these coordinates from the x-axis line. So we have one point at the origin, the next point was at like 1, 1, the other one was at 4, 2, and so on. So kind of imagine without a translation, let's just say if it was reflected, our x-axis would have been right there. So you can see our coordinate here would be like the origin, 0, 0, and then we went 1 over and 2 down. And then you can see this one over here is now 4 over and 4 down. Right, so you can see our spacing, so this distance was from 1, it's now 2 squares. This one was 2, it's now at 4. So from that, we have to sort of ignore where the actual coordinates are. We're just sort of looking at where sort of the spacing or how it changed vertically or horizontally. So in this case, The easiest way to look at that is to say, well, now we have a double vertical, right? Because it went from 1, now it's a height of 2. This one was a height of 2. It's now at a height of 4 from where the original place would be. Okay, so we've got that. So that means we've got a 2 times vertical stretch. And then the last thing is figure out our translations. We've got no left or right translating, but we can see that we went down 1, 2, 3, 4, 5. Our origin went 5 down. And that's it. So we should be able to figure out our equation. So we have, let's do it both ways. So we've got 5 down, so we could write it as y plus 5. We've got a vertical reflection, so we could put that negative out front if we want, or we could put it on this side. We'd have negative, and we did a 2 times vertical stretch, so that would be 2, and then just f of x like that. Okay, or if we wanted to just leave it as y equals, we could write it as negative 2 f of x minus 5 to show the 5 down. So either version would be fine, or you could write it even differently. We could put the negative 2 out in front of the y, so we could even have it as like negative 1/2 y plus 5 equals f of x, or whatever. There's lots of different ways of writing it. And just be able to convert from one to the other is the key thing when it comes to doing like a multiple choice test. And that's all.